So we're really excited to be able to present this paper at this conference as it's navigating the review process, only because the audience here I think will be really receptive to the idea that we're covering. More importantly, I have our PhD student on the market, Guang, who's been a fantastic asset as we navigate this paper. So if you are hiring, you should go talk to him after this presentation. He's absolutely stellar. The presentations yesterday, especially David Schweidel's and DK's that discussed the idea of actually like generating AI images, really kind of sets the tone for what we're trying to do in this paper. One of the key pieces that he brought up towards the end that really resonated with what we're trying to show is, do we really need A/B testing anymore? So if by some training data that we can actually start developing images, and those images can then be linked to some sort of outcome, do we really need to start doing A/B testing anymore? But on top of that, we have this cautionary tale of, well, LLMs may or may not actually be very good at decision making because maybe it acts like a human and maybe it doesn't. And so what we're going to try to show in this paper is, can we start linking the idea of an LLM or like the primitives to a functional form that we actually know and trust, which is a causal inference framework. So if we can come up with unbiased estimates of certain treatments, and given those unbiased estimates, can we start linking them to outcomes and actually develop new ones that didn't even exist in the training set? So to start off with, we can think that a lot of applications in marketing, we assume that treatment is binary. And oftentimes because of experimental design, that is perfectly fine. But when we deal with observational data, by nature of how the observational data is collected, we may be making certain assumptions just because we don't have the information or because of econometric tractability, so we'll kind of aggregate things up. But there's a lot of research that's going on right now of heterogeneous treatments, so not just the heterogeneous effect of a treatment, but what if I give you heterogeneous treatments? So what I have up here is an example of something you've probably seen in your email inbox that we could define as a treatment, which is extra 20% off clearance items today. It's very simple, very straightforward, but if you think about from an empirical standpoint, if I'm trying to address what is the lift of each of these different components, it becomes a very difficult problem. Like, do I purely code this up as a 20% off discount? Do I try to have something about clearance items in there? I have this little word extra sitting over there. I have today, I have an exclamation point. It becomes a very difficult, cumbersome problem that if we don't judiciously account for every element, we may be biasing our results. And so what we're going to try to do today is discuss a framework or an idea that will allow us to link this entire band of text into the causal inference framework to allow us to do counterfactual imputation and potentially even causal inference off of each element within this email subject line. Because as marketers, we often want to know what is the effect of each component, even not just marketing researchers, but marketing practitioners obviously want to know if I give you free shipping or if I have a clearance thing, what is that going to do? But they may even care about the combined lift of all these things together because there could be synergies. And so our proposed framework is going to be one where we have a latent multi-treatment double machine learning. So that's a lot of words going on there. But the idea is the following. Instead of trying to operationalize the treatment directly, we're going to use a latent variable. And that latent variable is going to be drawn directly from the large language models that we've talked about at this conference, and we'll continue to do so for the rest of today. It's multi-treatment because it's hard to understand the effect of the latent class treatment if you only have one observation. So of course we have to have many of them. And we want double machine learning because that allows us to extract what is known to be component level effects for the individual level. And so we're going to combine this together with the contextual embeddings from specifically ChatGPT. We're going to use the ADA embeddings to then create a response surface. So the response surface is going to be a mapping from the characteristics of the individual, the characteristics of the treatment to some outcome. And that outcome that we're going to look at today is the purchase. How much are you going to buy? Something that is actually very important to any sort of business, as well as understanding what is the influence of each individual object. And so we're going to do this between heterogeneous treatments and the outcomes. So why do we even think this is going to work? Well, this quote when we started this project really struck me from Stephen Wolfram, who was referenced in the presentations yesterday, is how is it then that something like ChatGPT can get as far as it does with language? The basic answer, I think, is that language is at a fundamental level somehow simpler than it seems. And this means that ChatGPT, or asterisk any large language model, is successfully able to capture the essence of human language and the thinking behind it. So underneath the hood of all that fun stuff that we do in developing text is a manifold, and that manifold is actually capturing what we're going to argue is the essence of language or context. So here's like an example. So imagine that We could take the 1,500 dimension embedding space and slam it down into 2 dimensions. And what we have here is animals and vegetables and fruits, okay? But this is developed because ChatGPT needed it. So the way it actually predicts text is because this has to exist. And so what we argue is that ChatGPT's embedding system works because it has estimated the sparse structure of language. So in essence, it has stripped out all the unnecessary stuff and created meaning in this kind of manifold. And that meaning is going to be a correspondence between the treatments, in our case emails, into this manifold space. So if language resides in one universal manifold that has been quantified, then we don't have to have necessarily a given object actually in our training depth. We can go a little bit outside the bounds. I'm gonna put little in quotes because what we're gonna try to do is define is what does little actually mean. So if you need a more concrete example, imagine you want to understand how much do people like these different objects. Well, if I know something about crocodiles, I probably know how much you like alligators. They're both reptiles. You know, the big difference is their snout structure and where they live. So corresponding the knowledge of how much I like one animal to the other one's pretty easy. It'd be much harder if, say, I know how much you like eagles, and I want to predict how much you like turnips. That's a much harder ask, unless I have a lot of information in the space. What we're going to do is take a very small aspect. So if I was using this further example, we know a lot about how people like berries. Can we extrapolate how much they like grapes? So if we can map how much people like the emails that we send, can we go just slightly outside the bounds and actually give you something you never in the training set by understanding the actual meaning behind it? And that meaning is the mapping that's going on here. Our application's email marketing, very standard. The reason why we chose email marketing besides the data that we have at hand is we have a very short text list. So we actually know the text, we can look at it very directly, we can use causal inference techniques to understand the components so we can see how these things are moderating. So that gives us a little insurance that we actually have variability that's going on inside the system. We have a 45-day window with 34 emails sent to an email list of 1.3 million people. They do some sort of rough targeting because we have residualized randomization in our data, which allows us to pin down causal effects. And our treatments are going to be our emails. Now, a natural question for someone who's skeptical is, do you really see variation that is meaningful to pick up these changes in outcomes? So what I'm going to show you is a PCA-reduced version of the embeddings that we get directly from generative AI, and specifically ChatGPT. So I'm going to show you 3 pairs. The first is 2 clearance emails, which are literally 20% off clearance, 30% off clearance. There's some other words around it, but that's distilling the idea. And if you look, they actually look somewhat similar. So I don't know if you've ever seen these black and white photos of like DNA. When I look at this, it's like the DNA of meaning. So each of these things represents some sort of unknown latent category or class within this manifold that describes the meaning of the variable. We can go one step further and say, well, here's 30% off of a product and here's 40% off of a product. Again, it looks somewhat similar. We have yellows over here, we have this dark stripe here, but then we start seeing refinements on down the line, which suggests there is something underneath the hood of comparing things that are actually very close to each other in meaning, because we know a 20% off deal versus a 30% off deal versus a 40% off deal, clearance versus products. Where things getting very interesting is the last 2. One of them is literally happy birthday with an exclamation point. Because one of the cool things about this is ChatGPT will also incorporate text. I'm sorry, not just text, but punctuation and syntax. So because of the transformer modeling here, we're getting interactions for free. So interactions between different components, interactions between the words, the syntax, and the order is all kind of baked into the system. And what you should see up here is the promotional deals that are dealing with percentages off all look somewhat similar. There's some differences. But happy birthday looks very, very, very different than everybody else. In fact, this is kind of like our feature, not a flaw in our system, where given that everything else resides very closely together, we're optimistic that things predict well. But happy birthday is so far different than everybody else, we probably shouldn't predict it well, and that's actually what we find when we do our analysis. Last but not least, I can't say exactly what holiday it is, but there is a holiday in our window that is not Christmas or any of those type, but there is an incidental holiday that happens where they start off with happy such and such. And so, again, you can see happy kind of loads up similarly, but it is also different. And so it's this variation within the embedding space that's going to help us to pin down our effects. Now, I'm not going to spend a lot of time showing a bunch of formulas. One of the nice parts about our paper, I would say, is we formalize what the conditions are that are required in the causal inference framework to actually do latent treatment extrapolation. So I've talked about our data. We're then going to extract out these embeddings from the ADA system in ChatGPT. We're going to process it using double machine learning, specifically a multi-treatment double machine learning framework. Since we have 30 treatments, those treatment propensities can get awfully small, so we augment it with sample weights for stability so that our estimates actually behave properly. That allows us to get something that is known as a pseudo outcome. So the pseudo outcome is going to be an individual level response to a particular treatment, and that response is going to be, how much are we going to predict that you're going to buy over a baseline email? So normally when you think of causal inference, your base case is somebody doesn't get anything. However, that need not be the case. You just need one common cause to kind of move things around. Since it's hard for us to understand how do people respond to an email without them actually getting an email or having a blank email, which doesn't exist, we cleverly find, clever, I'm going to put in quotes because I think it was pretty clever, we find an email that went to pretty much everybody. So that sets a nice baseline for us to compare how well do these other email promotions perform compared to this baseline email that went to pretty much everybody. But with these pseudo outcomes, these doubly robust scores, we can do a lot of nice things with them. We can aggregate them into average effects. We can look at group average effects for heterogeneity. We can do policy implications. And so it gives us a lot of room to maneuver. But more importantly, if we start linking these individual level outcomes through some sort of model, in this case it's going to be XGBoost combined with our ADA embeddings, will allow us to develop a response surface that allows us to then effectively estimate heterogeneous new treatments. We're going to explore this using a series of leave one out exercises, so the most stringent thing that we can do. So in essence, we build a model with the 32 differences that we have and then predict the 33rd that's not even in the system. And so that'll allow us to say, is this truly a new novel treatment because it's not in our training set? How well do we do? So we'll start with the average effects because it's just a nice baseline to start off and see how things are going. So again, we take our 32 combinations with all of our data. We've filled our model that's going to be our response surface between the the latent states of meaning, as well as the components of the individual. And then we're going to project out an email that didn't exist in the training set and see how it does. The nice part is we have the ground truth because we see how the email actually responded. What we have here on the left is an ordering of where does that email rank in actuality in terms of performance against our prediction of where it ranks in terms of performance. And what you can see is except for 2 emails that kind of switch, we nail every single one of them. In fact, we nail the most important ones, which are the better performing ones. The low ones we have a little bit of difficulty with. Now one may ask, why do you need to do this? So if you believe that ChatGPT actually internalizes information of customers, why not just ask ChatGPT which one's the best one? So if on average people would respond to this stuff, why not just say, ChatGPT, tell me which one is the best one? You get this. Now we simulated it, we changed the order, we did a whole bunch of stuff, and unfortunately, we couldn't get it ever to reconcile itself. So what this says is, you want to actually adapt and have something in the system, and instead of humans, we have the model. If you want to look at point estimates, we actually have 93% overlapping confidence intervals between the confidence interval of the actual ground truth and the prediction interval. And if we regress the two on each other, we get an overall R-squared of 78%. So really good performance, even with only 32 observations to predict this down. We do heterogeneity. So we create gated average treatment effects based upon the observed data. We then collect the predictions for the leave one out predictions, we regress them. And we find the median R-squared to be 66% with a range of 45% to 83.5%. So we're actually capturing the heterogeneity inside the email, not just the average effect. We go one step further and actually do policy learning. So Athy and Wager 2021 has this policy tree algorithm, which lets us say, what if we have 2 different options or multi-options, who should get which? So this is going to explore the dimensionality of the characteristics of the individuals even more effectively. When we do these policy exercises, we find ratios to create correct predictions between the actual observed scores and our extrapolated scores to be 82%. So this shows not only are we able to capture the average effects, but we can actually capture internal heterogeneity. Now, something that is not in our paper that we are currently working on and revising is we go to ChatGPT and say, look, here's how the emails performed, here's what the emails are, start ideating new emails for us. And then we can start plotting where they are. So here's happy birthday sitting all the way up there by itself. Now we're starting to ideate actual emails that are performing just as good. But what's nice about this exercise is we can actually figure out how far out can we go. So since we can't observe the embeddings themselves, we want to know where there's this idea of feature saturation. Where do we have confidence that the prediction is good versus bad because we're going very far outside the system? And what we find is a Euclidean distance of 0.64 or less has trustworthy prediction. We use Euclidean distance because there's current literature that says, can we actually use cosine similarity as a measure? There's a little bit of uncertainty, so we use Euclidean distance between it and different emails. We're currently augmenting this with an actor-critic algorithm because we don't have direct access to the overall LLM manifold. So what we're going to do this is allow us to learn what it is, both at the aggregate level as well as the heterogeneous level, to do individual targeting that is optimal. Last but not least, we're considering causal inference. So if you believe what I've been saying for the past 15 minutes, that we can actually extrapolate credible counterfactuals, then why can't we recover the individual components again? So given that we have this latent class of meaning, we can start perturbing, well, what if this one option exists or not? And then if we just do the counterfactual prediction based upon the characteristics, we can aggregate and start doing counterfactual estimation, and thus actually measure the latent characteristics that we had to kind of ignore in the beginning step. So I'll leave you all there. Thank you so much for your time.
We probably have time for one question, one or two questions.
Hi, thanks for this very interesting talk. I had a question on the embeddings themselves, and you mentioned towards the end about actor-critic models. I'm wondering if you were to use open source LLMs, or even the traditional BERT, right, where you have access to the entire model, would that provide the sort of information that would need for the embeddings to be more amenable for and what's going on?
That's a great question. We don't want to train an LLM model on our outcomes for two fundamental reasons. One is there's some new research that says if you start fine-tuning LLMs, you start having potential for greater hallucinations. And of course, if we're trying to pin down precise estimates of treatment effects, that's really bad for us. More importantly, directly operationalizing customer characteristics in an LLM model is not intuitive how to do that. Like, would you write the email first and say, this email was sent to, Carol, who's a 45-year-old mom that has bought this for the past. It's hard to conceptualize how to do that. So instead, we use just XGBoost because it's much cheaper for us to just run an XGBoost and basically buy the embeddings off of OpenAI rather than having to fine-tune our own model as well. Thank you.
One more question?
When you look at your data, you said there's one email that went to everybody, that was your baseline.
Almost everybody, yeah.
But am I somebody who had 5 exposures and somebody else had 3 exposures? Like, I could have purchased the third email. Did you control for that?
So we did a lot of robustness tests. And so one of the things that we looked at is, does the prior email that you got impact your purchase now? And we find that it doesn't. So there's a lot of kind of forgetting that goes on. More importantly, and I didn't talk a lot about the data, but the CRM data updates every time you're targeted. So if you did purchase on the last email, that's updated in the system. So by default, that's actually kind of kept inside the system of the tracking covariates that we have. But to your other question, so if you want to go a little bit further, is like an attribution problem. That is a big issue, but we believe that this could actually handle it because you could theoretically stagger or stack up the treatments in a row and then get the meaning from them in the latent embedding space and then do the same thing that we're talking about. It's just a little bit more complicated to see how do they interact with each other.
Because I have, as a marketer, I have a sequence of emails not in a programmatic way, and the multi-email attribution is a challenge.
But I think this could handle it, only because of how the embeddings are able to distill meaning. And so you just have to assume that people, when they get this sequence of emails, have the exact same meaning. And then as a result, you'd have the interactions because of the transformer model as well. It'd be a little bit difficult to say which email's performing the best without doing a little bit more work, but I think we could probably pull something like that off, absolutely. Okay.
James, in essence, what we are trying to do here, like when you talk about counterfactual, you are talking about like using text as input and say like never appeared text, how would that affect the causal effect? Not like out of distribution text that never appeared anywhere in the text. Like, so I'm trying to get the essence of the method.
So what we have is sometimes we'll have an attribute that didn't actually appear in the model. So for example, free shipping only appears once. So if we're trying to predict out what is the value of free shipping, then if we're using a classical method, we can't do that because we don't have a value for it, right? You do like classic conjoin, you say, what is the value of free shipping? If that's not there, you can't do it. We're making the argument that by looking at a particular piece of text, there's meaning. And so we're basing our model on what that meaning is and how that meaning then maps to outcomes. And so in essence, if we put free shipping in that never existed, it changes the meaning or it changes the embedding level, which is then going to be mapped out with the response surface into new counterfactuals. And what we show is, using our leave one out exercises, if free shipping didn't exist, because it wasn't in the training set, we can still extrapolate out into a region of free shipping actually existing.
Because of the semantic space.
Correct. Yep.
All right. Thank you so much.
Thank you.